This video is about the data transfer process between Autodesk Revit and SmartWorks Viva. For this example, my task is to lay out the pile caps supporting the ground floor of a building. The first thing you have to do is create a view that only shows this floor. Next, I will create the control data out of the building model, which will later be used in the field to set up my total station. I select the corners one by using the Measure Point tool of the Leica Building Link plugin. Because you never know what obstructions will be on site, I will select more control points that I actually need for my setup. I give them the code name CTRL to be able to later filter for these points in the field. In addition to the control points, I will stake out points from a mixture of 2 and 4 pile caps. These points can be generated automatically using the family function of the Leica Building Link. With this method, it is not necessary to manually pick each corner of the pile cap, as we've done for the floor corners. Simply measure one sample, and then the points for all the other similar objects in the model will get created automatically. I will also add a different code to these points, so I can filter for them later in the field. If I wish to, I could assign attributes and annotations to the code for extra information in the field. Finally, we load the family back into the project, which automatically creates the corner points for all of the 2 pile caps in the model. Then I repeat the same process for caps with 4 piles. Now that I've created my points, I want to export them for use in the field. First, I'll select the area of the model to export, and then use the function export XML. As you can see, I've created 320 points, which all get stored in a XML file. Additionally, I want to create a DXF file from the floor plan to use as a background image to make it easier to orientate myself in the field. In SmartWorks Viva, I'll firstly create a new control job and then attach the DXF to it. Then I'll import the 320 points from the XML file to this job. I will use this control job to select my design data from. For my stakeout points, I will use a separate working job, in my case named Stake Cap. This job will contain all my measurements done in the field. With this done, I'm ready to set up my Leica Viva total station. When I first enter the data panel, all 320 points are shown from the control job. As I only want to see my control points, I will select to filter by the point code CTRL. An easy way to select a control point is to use the map screen. In this case, I select and measure the target points 8, 7 and 1 for the resection. My total station is now orientated and I can start to stake out the pile caps. Now I will use the stakeout application and filter to only show 4 pile caps points. I do not need to remember the stakeout point's ID, as I can simply select the point from the map. I navigate to the position of the point, and after staking it, I'll store the point to later compare the difference between the design and staked point. I will use a style sheet to quickly create a stakeout report, as I want to compare the difference between design and staked points. In this sample report, you can see that the stake points outside my defined tolerances are marked. I will also export an XML file in addition that contains details of all the points measured in the field. Using Revit once more, I'll import this XML file back into the model. As shown in the XML import dialog, all field measurements, setup observations, but also my staked and measured points will be imported. As I've imported all my field measurements, I can compare these visually with the design model. In this case, I can see that my staked pile cap points are aligned with the design. I can also use my station points for further modelling. As you can see, I can extend my Revit model with real-world data.